This is 3.5, number 77. So in this one, the key word here is they're looking for a continuous function. So we know cosine's continuous, 1 is continuous, so we know this is continuous, and 2x is a polynomial, that is continuous. So this will be continuous everywhere except where the denominator could be 0, and that would be at x equals 0. So that's the only point that's an issue so far. And so at this point, we need to get the definition of continuity and see if it meets it at 0, because that's the point of issue. So to prove continuity, I have to show first the limit as x approaches 0 from the left of my function, and the limit as x approaches 0 from the right of my function, and the function at 0 will all be the same. The question is, what function do I use here? So this is numbers really close to 0 from the left, but not 0. So this function works everywhere except 0. So since it works everywhere except 0, I can, hold on here, I can use this for the limit from the left. And it's going to be the same one from the right. And how are we going to do this? If you plug in 0 here and 0 here, cosine of 0 is 1. You get 1 minus 1, which is 0, over 0, which is indeterminate. And so we're kind of stuck and not sure what to do at this point. But here's the secret. You can try rewriting this. You can try all kinds of stuff. But this comes from the Squeeze Theorem. And this theorem was given to you. If you remember, the theorem said the limit as x approaches 0 of 1 minus cos x over x equals 0. So the only difference is that 2. So I can pull that 2 out in front, and it becomes this. And by the theorem, we know that's 0, so that equals 0. And similarly, this is the same thing. That's going to be 0. So in order for this function to be continuous, all three of these must be equal. So the last one must be 0, right? So f of 0 must be 0. What's the value of g? Actually, it's g and not f. I've been saying f. What's the value of g at 0? Well, at 0, it's a. So a must be 0. So the answer is a must be 0 to be continuous, and that will plug the hole.